Descriptive statistic means a statistics that summarizes two things. One is central tendency and spread. All of you type CT and spread. CT and spread. Okay. Now that is what is distribution of data. Before I explain you, I will tell you an example. If there are 100 people in your class and you measure the height of each and every person, and let's say the central tendency consists of three things. One is the average, which is also called as mean. All of you type mean in the chat box. That is the central tendency. Mean is the standard central. All of you type mean in the chat box. And you might also have ask everybody to stand in the ascending order or descending order and pick up the middle person. That is also central tendency. That is called as median. That is called as median. Or sometimes you can pick up those people who are having almost same type of height, and that is called as mode. Type MOD, mode in the. So the measures of central tendency is either mean or median or mode. Okay, all of you type 3M in the chat box. Mean, median, mode. Excellent. Okay. So with that simple example, I will say 50% of employees work in sales and marketing departments, or 80%, 86% of the employees live in some same region or something like that. These are all describes the data. Okay. So these are descriptive statistics because they simply discuss the nature of data in hand. Average, means, or even standard deviations associate with the nature or describe the data. Okay. Standard deviation is called as a spread. I will also talk about the three measures or four measures of spread. Okay. One is called as a range. All of you type range in the chat box. Because mean, median, mode, we said central tendency. Okay. The spread is range. Range is maximum minus minimum. That is one spread. Okay. Because the tallest person was the shortest person. The difference is the range. The second is called as variance. And third one is standard deviation. Variance and standard deviations are interrelated because the square root of variance is standard deviation. Don't bother about all this formula, but know that this is a measure of spread. Okay. The other thing is called IQR, interquartile range, which I will also explain to you. Okay. And this is a dry subject, so I wanted to make it as interesting as possible. So please hold on, even if you miss the bus. Even if you miss something, don't worry about that. Please hold on. I will share this recording also. Okay. So you can curate your learning after watching my videos. Okay. So all of you keep focusing. That's enough. Not everything can be understood at the first shot. Okay. Now, we will review the descriptive statistics shown here, which are commonly used. Okay. For each of these measures of location, how alike or different are they? For each of the measures of variation, measures of location means mean, median, mode. It's a central tendency. Okay. Measures of variation means the spread. Okay. How likely, how alike or different they are. And what do the similarity or differences tell us? Okay. Mean, median, mode is something that we have seen as the measures of location, which is the central tendency. And measures of variation, I've already said range, interquartile range, standard deviation, and variance. Okay. So far, if it is clear, please give me a 9 or 10 if it is super clear. Okay. And again, I'm telling you, these are all some fundamentals of statistics. You have no option than to know these fundamentals. Okay. So don't be scared. Don't get bored. Okay. If you really want to solve the problem, database decision making, you have to know about how you describe the data. Okay. If you really want to handle one person and move with some person, you really have to describe or understand that person. How many of you agree with me? Type agree in the chat box. Particularly bachelors here. particularly bachelors here. If you really want to understand your partner, okay, you have to first describe, okay, what is the average nature of that person, okay, and also how varying personality they are. Analyze them before even getting into. If it is clear, type super clear in the chat box, okay. Good, okay. Nice, thank you very much. This is on the lighter side just because, Now, many of you would have observed cricket scores. There's something called as an average run rate, okay. Every over, how many runs that are scored, and total runs divided by number of overs, there will be an average scorecard, okay. Those who are interested in cricket, you would have wondered during the match, why a run rate of a particular over is projected, right? Or when you get an examination result card, you get the aggregate percentage, okay? So you have to understand the meaning of aggregate, you'll have to understand the meaning of average run rate, etc. All these quantities in real life make it easy to represent a collection of data in terms of a single value, and this is called statistics. Okay, all of you type statistics in the chat box. I'm going a little faster because I've already done this. I wanted to recap this and go to the inferential statistics today. So measures of central tendency is, all right, thank you very much for active participation. Let's focus here. Measures of central tendency, the statistics that deals with collection of data and information for a particular purpose. The tabulation of each run for each ball in cricket gives the statistics of the game, correct? Because we have in football also, we have in basketball also, a lot of data that is put. That's called statistics, right? And you represent it in multiple ways, particularly graphically. It can be pie charts, bar charts, many pictorial representation. And this is the measures of central tendency are given by various parameters commonly used, that is mean, median, mode. Now, the measures of central tendency is represented by various values of the given set. If the data is symmetrical, that is 50% of the data. For example, if the average height of the people in the class is 5 feet and 50% is above 5 feet and 50% is below 5 feet, let's say that 4 feet to 5 feet, 50 boys are there, 5 feet to 6 feet, then mean, median, mode all are same. Suppose if it is skewed, it is called positive skewed, or this is called actually right skewed, and right side is called as left skewed. It depends upon where the tail is, okay? Where the tail is. Tail is on the right side, it's called right skewed. Tail is on the left side, it's called as left skewed. So the mean and median will be represented like this. You can understand from here. So there are various ways to represent the measures of central tendency, and we know these are the symbols that I used. Now earlier I just showed you simply mean, median, mode. Now for mean it is either x bar or mu. For median it is capital M. For the mode it is Z. Now what is x bar or mu? Let me explain to you. There is something called as population. There is something called as sample. All of you type PS in the chat box. P for population, S for sample. Okay. Now, we all know by the word population itself, population means very large data set. Sample means small data set. For example, India's population is, let's say, 144 crores, okay? And sample means you can take a few lakhs out of this and ask them, okay, which party do you like? Okay, there are few parties in India, okay, BJP, Congress, Aam you can ask, okay, which party do you like? Like, for example, here there are over 500 people in this webinar. Suppose if I ask the Indians alone, which party do you like? Okay, what party will you pick up? BJP, Congress, Aam Aadmi, which party will you pick up? Just put it in the chat box. This is just for a for you to tell, because not all 500 people are going to type. Okay, not all 500 people are going to type. Okay, so you could see from the sample. Okay, I will just wait for 1 minute. I'll just wait for 1 minute. Let's see which are all the parties for the Indians that are showing up. Okay, fine. I will stop with this. Okay, and the data points that I've got. Okay, the data points I've got is at least, let's say we've got. Okay, right. So thank you very much for sharing. And the people from abroad, with this, though there are 500 plus people in the webinar, I have asked Indians alone from that. Indians is a sample out of that. Out of that, only few people participated. I want the foreigners here to infer which party is famous in India. All the people from abroad type, from whatever that they have typed, which party do you think is famous in India? So all the foreigners are typing BJP, BJP, BJP because, and this is called inferential statistics. This is called inferential statistics. That is, while we have a large audience of 500 plus people, and we have a sample of Indians, out of the sample of Indians, only maybe 50 people have participated. The conclusion that foreigners have drawn is BJP is the, that is called inferential statistics. The idea is not to create politics here. The idea is to explain to you, we are making a conclusion based on the sample and the sample result about the population that in India, BJP is famous. If this is clear, if this was interesting, useful, valuable example, just put it in the chat box, okay? Okay, descriptive statistics. Let me go into the detail of the descriptive statistics. Thank you very much. And this is inferential statistics, okay? Okay, so example of central tendency is 50 over one-day match between India and Australia. India scored 370 ranks. How do you decide whether India put a good score or not? Okay, it's pretty simple that from overall run rate, you find which is good for such a score. Okay, find out mean, median, mode, find out central tendencies, etc. We had discussed this last time. Okay, now this is very important. You can take a screenshot of this slide. Okay, that this is very important. The mean, median, mode is all same when it is a symmetrical distribution, but mostly a distribution may not be symmetrical, and so the mean, median, mode will differ, and depending upon that, we will pick which is the best means of describing the data. So the mean is adding everything and dividing by this, and we said we all know that the mean is adding everything and dividing by the total. We know this, okay? And median, we generally said last time, though I have given this formula, we said that arrange the sample data in the ascending order or the descending order. Pick the middle value. If it is an odd number, if it is an even number, the middle two numbers and take the average, okay? That is what is median. And mode means the maximum occurring. For example, in this example that we showed last time, 73 is occurring quite frequently and 73 is mode. Okay. So if mean, median, mode is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear. Superb. Okay. Thank you very much. Now we will discuss about the measures of variation, that is range, interquartile range, and standard deviation and variance. Okay, we will go into the depth of this. You see, this is a normal distribution, and this normal distribution, if it is symmetrical distribution, let us say that this is the center is the average. We actually divide this data set into 4 parts. Okay, 25%, 25%, 25%, and 25%. And the center 25% plus 25% is called as the interquartile range. I'll discuss that in detail. Okay, so range is nothing but maximum minus minimum. Okay, maximum minus minimum. All of you type max minus MIN, the largest observation minus smallest observation. So I'm not going to explain all these words here because it is as simple as that, range. But then interquartile range is something that I want to spend some time. Suppose if you have 1,000 data points, okay? Suppose if you have 1,000 data points, let's say you divide the 1,000 into 4 parts. 250 data points here, 250 data points, 250, 250, so 25% each. After 25%, it is called Q1. 0 to 25 is called Q1. 25 to 50 is called Q2. And 50 to 75 is called Q3. And finally, Q4 is the end. Okay. So Q3 minus Q1 is called as interquartile range. If IQR is clear, type super clear SC or crystal clear CC in the chat box. This IQR understanding is important. So basically, you divide the data set into 4 parts, and the first 25% you leave, the last 25% you leave, the middle 50% you take. That is the interquartile range. Okay. So now that you have understood interquartile range, and statistician defined that as Q3 minus Q1, don't worry about that. First 25% is called Q1, next 25% is Q2, next 25% is Q3, next 25% is Q4. Okay. Where this is used is something that we will see later. Okay. Now, if you see here in this description also, there are numbers here 45, 47, 52, 52, 53. So this is the lower half, this is the upper half, and you divide that into 25%. How many data sets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them are there. Okay, so you logically divide that into 20, 20, and then you find out the interquartile range and all that you can find. The example is given here. Okay, so this is the interquartile range. Formula is the upper quartile, lower quartile, known as interquartile range. So Q3 minus Q1, which I have seen in the last slide. Q1 is called first quartile, Q3 is called as a third quartile. Okay. Okay, now standard deviation. Standard deviation is nothing but how each of these points, each of the data points is deviating from the average value. Okay, you have an average value of the data set. For example, to explain the standard deviation, I would like to bring your attention to your marks, okay, mathematics marks. For example, if there are 100 students in the class and the average marks is, let's say, 70%, okay, 70 marks, 70% out of 100, 70 marks out of 100 is the average. Suppose if somebody has scored 60, then he's 10 lower than that. If somebody has scored 80, he is 10 higher than that. So one person is plus 10, the other person is minus 10. But both of them are deviating 10 marks from the average. If this is clear, type super clear in the chat box. Both of them are deviating by 10 marks from how much they are deviating? Only 10 marks. The average is 70. One person is 60. One person is 80. One person is plus 10 marks higher. One is minus 10 marks, which is lower. Now, in case I wanted to find out this 10, what I will do is, I will say 60 minus 70, which is minus 10, squared under the square root. So 60 minus 70 is minus 10. And if I square that, it is 100. And I take square root of that, again it becomes 10. So the minus 10 becomes a positive 10. And similarly, 70, so 70 minus 60 or 70 minus 80. 70 minus 60 is, one is positive 10, one is negative 10. So generally it is whichever way that you take, if you square it and square root it, it will come back to the original number. Okay, if this is clear, on a scale of 1 to 10, please give me a 9 or 10. That is the whole idea of the squaring and square root. Okay, it's not the absolute value. Okay, It is called RMS actually. Root means square. That's a concept in mathematics. I'm not going to discuss that concept here. Okay. So the point here is, if you see here, xi minus x bar. Okay. This is x bar. Actually, the thing is missing here. The average. So each point from the average, square it and then square root it. So that's a typical formula. I'm not going to explain all these things, but what I want to communicate to you is standard deviation is deviating from the central tendency, which is the average. Deviating from the central tendency, which is the average. You can imagine like a dartboard. Okay, this is not deviating. This is deviating from center. This is totally deviating from the center. This is all spent. So you can imagine the dartboard which is deviating from the central value. Suppose if you see here on this bottom left side, it is not deviating from the average, but it is deviating from the target. Okay. So in variation calculation, standard deviation, we always see the deviation from the average and not deviation from the target. This is something that I want you to understand. For those who are clear, you can give me super clear in the chat box. Okay. That's why standard deviation is always with respect to average. It's not with respect to the target. Good. Okay. Thank you very much. There is a lot of active participation today. So it is the most popular measure of variability. Okay. Standard deviation for a sample and population can be equated with short-term and long-term variations. And usually sample is taken over a short period of time, making it free from types of variation that accumulate over time. Like variance, if data points are close to the mean, then small variation. Okay, don't worry about that. It is just saying that whenever you take samples in the short term, the variation is less. If you take samples in the long term, the variation is more. For example, if you're filling a bottle of water, if you take in 5 minutes, the variation will be less. But if you take over 5 days, the variation will be more, because there are other factors such as machine settings, the operator settings, man, machine, method, materials, and all that 5M, 6M will come into play. Okay, that's what this says. I hate reading the text. Okay, that's why I'm just going little fast forward. Okay, standard deviation calculates the extent to which the values differ from average. Okay, standard deviation is most widely used to measure of dispersion. Okay. And therefore, the change in even one value will affect the value of the standard deviation. It is independent of origin, but not of scale. It is also useful in certain advanced statistical problems. Now, this is the formula, okay, and mu is called as the average of the population. Okay, so this is the formula that is given here, and sigma is the population standard deviation. N is, so there is some, as I told you, there is something called population, there is something called as a sample. The population standard deviation is sigma and population average is mu. Whereas if you take sample, then sample standard deviation will be S and the sample average will be X bar. Okay. So this is the formula and these are the representations of the formula, and this is self-explanatory. So I'm not getting to this. And most of the standard deviations are calculated by the formula. So don't worry about how it is calculated. Just know that there is a formula for this. Okay. Otherwise, it will become too dry and many of you will drop out. And similarly for the sample. Earlier we spoke about population and now we are talking about the sample. And only two things are changed. This S is the standard deviation of the sample, while sigma is the standard deviation of the population. Here X bar is the average of the sample, whereas mu was the average of the population. Okay, that's the only difference. Don't worry about that. Variance is, okay, is the square of standard deviation. I'm not going to read all this. Okay, variation and standard deviations are both the same. Variance is the square of standard deviation. Sigma squared is variance. One rule I will tell later. Okay, standard deviations cannot be added, variance can be added. This is the only thing, because some people will ask me this technical question, then why these are two formulas, why we can't use one? Variance can be added, standard deviations cannot be added. Okay, if it is clear, type super clear in the chat box. Okay, for example, there will be a process variation, there will be a measurement variation. So the total variation is process variation plus measurement variation. Okay. But if you calculate the process standard deviation and the measurement standard deviation, you cannot add these standard deviations. Okay. So that's why these are all two things. Be careful of that. Okay, so population variance formula is sigma squared, where the square root is removed. Okay, and sample is same. The sigma is replaced by S and mu is replaced by X bar. And variance is the square of standard deviation. It's a common statistical test where it is necessary to add up the sources of variation to the estimated total. Okay, so you cannot add up standard deviation, so you calculate variation and add up. Okay. Standard deviation cannot be added, variations can be added. Okay. Now, how many of you are ready for Q&A? Type ready in the chat box. Only 3 questions I have. Only 3 questions. Okay. If you're super ready, then which of the following is not a measure of central tendency? Okay. Mean, median, standard deviation, mode. Answer is simple. Excellent. So standard deviation is the correct answer because we know the measure of central tendency. We've been crying for so long that mean, median, mode. The second question is, what does the histogram primarily show? We have seen the histogram. Relationship between two variables, distribution of a data set, frequency of categorical data, comparison of multiple groups. This is little technical. Unless you know this histogram, you cannot answer this question. Oh, good. Many of you have answered well. Please understand this categorical data is written here. Please understand this carefully. Distribution of a data set is the right answer. Okay. All of you type B in the chat box. Stay yourself corrected. Okay. Fantastic. Okay. If the data set has outliers, what is an outlier? Outlier is something totally different from others. For example, if most of you have scored between 40 to 50 and somebody has scored 84, 94, in my class, one guy used to be there. All of us used to flunk, and this guy used to score 94. Okay, that he's called outlier. Okay, suppose in the Indian school, suddenly one African who is very tall comes. We are all short. We are all 5.5, 5.5, and one person who comes 6.5 feet, he is called as an outlier. Okay. So if the data set has outliers, which measure of central tendency is least affected? This word least you should understand. Okay, which measures of central tendency is least affected? Let's see who gives his answers good. Very good. People who typed median, it is the right answer. Okay. Median is the right answer because median takes the middle value. It takes the middle value. So even if the tallest person stands in the ascending order, if you take the middle value, the whole central tendency is not going to get affected. Imagine that the tallest person, 7 feet, is standing. Others are all right from 5.5 feet to, let's say, 5 feet. Okay. Or probably 6 feet. But still the middle value is not going to affect much. Okay. So that's the median. Fantastic. Okay.